How is this possible? This 110 billion parameter model, Qwen 110 billion, is running on this machine. But even my 5090 can't run this model. I'll tell you how. This little device has 128 gigabytes of unified memory on board. Oh, unified memory, you say? Is that kind of like Apple's unified memory in this M4 Max? Not exactly. And this does affect LLM performance, which is what I'm going to be digging into here right now. This thing, of course, is the Asus Flow Z13 2025 edition, and that's the first device to have AMD's new Ryzen AI Max Plus 395 APU, or known as Accelerated Processing Unit, that combines both the CPU and the GPU together on a single chip. And that means that the GPU can have access to the absurd amount of memory that's shared with the CPU. Shared? Maybe. And as of about a week ago, these were the only two laptops that had 128 gigabytes of memory. But this is becoming more common these days, especially with more and more people interested in running local models, local LLMs. But wait a minute, my phone with 8 gigs of memory, or however much is in the iPhone, I don't know, that thing can run LLMs, and so can this 16 gigabyte MacBook Air. In fact, all these laptops can run LLMs. So why would I care to get 128 gigabytes? Isn't that expensive? Well, yes, it's very expensive for now. And the reason you care is because larger models like Llama 370 billion, for example, they often outperform smaller ones since they store more knowledge and maintain longer reasoning chains. That just means fewer hallucinations and better performance on complex tasks like math or legal arguments, for example. We're gonna make that assumption here. We're gonna assume that bigger models give you better results because there's a ton of quality benchmarks out there that show results. And going forward, we're going to focus on the other performance side of things, which is how fast they can do stuff. Oh, look at that, 2.12 tokens per second. So this whole thing depends on the hardware you're using, what the CPU is, what the GPU is, how much memory bandwidth you have, and so on. So what I did was I picked a bunch of these models that I've been collecting over some time. I don't keep all the ones that I collect, but you know, just a few. I don't have all these models on all these machines, but I have enough to get a sample so we can compare things. And some of these I run on a regular basis, especially vision models where I need to automate some local scripts that look at thousands of pictures and then describe them. This stuff would be really expensive doing in the cloud. So this is 128 gigs on this one. This one is another model of the same thing. It's the Flow Z13, but it has 32 gigs of memory. Now, the reason I found out about the Qwen model is because a regular commenter on the channel asked me specifically about that one, and that happened to coincide with the size of the model that's just big enough to fit on this machine. And if you go bigger, it does not work, even though it looks like it should. It looks like it should, but it doesn't. So for example, here's Llama run, and I'm gonna try this one, which is 73 gigabytes in size on disk, not in memory, by the way. I gotta mention this. The size on disk of the model is not necessarily gonna be the size of the model when it's running in memory. It's just gonna give you an approximate starting point. So don't always go by that. In fact, I made a LLM calculator recently in one of the videos. I'll link to that down below so you can check out what the running memory footprint could be. Also an approximation, by the way. So let's do this one, Mr. Large latest. And this machine should be able to handle that. Having, you know, 128 gigabytes available. It's not even how it works on Apple Silicon either. This MacBook Pro with the M4 Max also has 128 gigabytes available, but not all of that is available for doing LLMs on the GPU. By default, you get about 96 gigabytes. You can override that, of course, get it a little bit closer, but then you're running the risk of the system becoming unstable. Now, if we take a look at this, you'll see that Mr. Large is not giving us the best results, but it is running. However, this is not running on the GPU. This is mostly running on the CPU. Take a look at the memory footprint. You'll see that system memory has 128 gigabytes and 125 of that is being used up. However, the GPU not being used at all. 288 megabytes. What's that? And that's because Llama, the tool that we use to run LLMs, sometimes decides on its own how to distribute the load between the GPU and the CPU. If you want more control over that, you have to use other tools. For example, LM Studio is another one. And if I load a model in here, I'll be able to decide how much should be offloaded to the GPU. All of it, or some of it, or none of it. If you're not gonna offload anything to the GPU, it's gonna run fully on the CPU, which means it's not gonna be giving you the best performance speed-wise. If you go half and half, still not the best performance. The best performance is if you're running fully on the GPU here. So here the model is loading, and you'll see that we're getting some memory usage on the GPU, but we're still pretty high on that CPU memory usage. We shouldn't be. I think Ollama didn't unload fully, so let's quit it. Okay, good. For some reason, Ollama didn't let go of the model, even though I said bye to it. Look at that. Now the memory is going down. Now we should be able to load things in LM Studio. Let's load this smaller one so we can just see it quickly. I'm gonna load 34 layers onto the GPU. And there it is. It loaded. So if I say something like hi, it's going to answer me pretty quickly. 51 tokens per second for the Gemma 3.4 billion model. Now, the reason I said hi to it is because I want to get the fastest possible speed. It's not a realistic example of what you're going to be doing with an LLM. You're going to be asking it much deeper questions probably, like what's the meaning of life? But hi, it's like a 1 token prompt, and smaller prompts yield faster results. Watch, I'll prove it to you. Write a 1,000 word story. This is a little bit of a tangent, but I think it's worth mentioning here. And whether I ask it to write a 1,000 word story or I ask it to write a piece of code should not matter that much. All that matters is the length of the prompt. And if you're using just the model without speculative decoding, I'll go into that in another video, then the output you're getting should pretty much be the same speed. So here we got 42 tokens per second instead of like we had previously, 52, because the prompt was longer. What I can do further is just copy this story and send that in. Now you can see the speed of this has drastically slowed down. And if I stop this now, 41 tokens per second, so a bit slower. If we go to Task Manager, you'll see that we have 288 megabytes dedicated GPU memory. What's up with that? Why not 128 gigabytes? That's what the system has, right? Well, you can actually predetermine how much memory goes into the machine. And that's where the big difference comes in between this new APU by AMD and something like Apple Silicon. I'll get into that momentarily. Tell me, which developer builds trust? The one typing or the one actually listening? This tiny Plod node pin turned me from a distracted note taker to a focused problem solver. I've actually been enjoying using it for the last few months, and I can start recording anywhere, anytime with a single tap. Hands-free, no fumbling for a phone app, and zero risk of an incoming call wrecking the capture. Because the audio lives on the node pin itself, it doesn't use up the phone battery or storage. I stay focused on my meeting, not the battery gauge. Node pin gives me 300 free minutes of clear, speaker-labeled transcripts each month, and that's perfect for stand-up meetings. Unlike Apple Notes, which needs iOS 18 and a $1,000 iPhone, Plod supports 112 languages and works on almost any device. Plod AI, built on top of GPT-4o, O3 Mini, and Claude 3.7 Sonnet, instantly pulls out key takeaways, decisions, and action items. You can pick from over 30 templates or customize your own. Later, I just ask it, when do we discuss adding dark mode? And Ask AI jumps in to that precise second and can pipe the answer into Jira or Slack. It weighs just 16 grams, records 20 straight hours, and clips anywhere. Lapel, lanyard, I prefer wearing mine on my wrist. Hands-free, distraction-proof, and totally discreet. But always make sure and ask for consent before hitting record. And by the way, everything is locked in AWS with HIPAA-grade security, so client info stays private. Let Plod Note handle your sprint notes. Link is in the description, and in 2 weeks, I'll send a free note pin to one random commenter from this video. Gotta live in the US though. Now back to the show. For now, I want you to see that there is a piece of software called Armory Crate on Asus machines, which allows you to free up memory and to basically assign the GPU a certain amount of memory. So here, I can assign it half a gig, 1 gig, all the way up to 96 gigabytes. But notice when I select an option, I have to reboot my computer. On this 32 gigabyte machine, I don't have the same options. I have up to 24 gigabytes available for the GPU. And still, if I select something else, I have to reboot my machine. So why wouldn't I just leave that on auto? After all, isn't auto going to determine the best course of action for me? Well, not always. If you ask people that drive automatic transmission cars, they're gonna say, hey, I like it. If you ask people that drive manual transmission cars, they're gonna say, automatic doesn't let me do what I want. Same thing here. Auto, having that setting, it looks like we're not getting barely anything in the dedicated GPU memory here in Task Manager for this Radeon 8060, but our model still runs, so that's good, right? Well, not exactly. I ran a bunch of these models. I ran all of them and on all the different memory settings. If we take a look at this chart, for example, and we take a look at auto, which is this light blue one, you'll see that the performance of auto is always way worse. Well, not always. In this case, 64 was worse on Llama 3.2, but generally, the performance of auto is worse than manually selecting one of the memory options. However, if you select the memory option, it's generally better. Some of them are better than others. 16 seems to be doing pretty well. 8 is doing well. 96 is doing well. And so is 32. 1 gigabyte, if you select 1 gigabyte for the memory option, it's not doing well. And neither is 64 in these two cases for these two models, Gemma 3 and Llama 3.2. Not sure why that is, but down here 64 seems to be doing okay. Just up here it's not. But generally seems like auto is not the best option. So let's pick a different option. And I would tend to think that if I'm running a large language model, then perhaps I want to have 96 gigabytes, right? I want as much as possible available. So I'm going to select that and reboot my machine. Why did I have to do that though? That's kind of a bummer. Well, it comes down to architecture. While they call it unified memory here, it's not true UMA or unified memory architecture, where the CPU and the GPU share a space, minimizing data movement between, well, the CPU and the GPU. It's more like they can share memory here, but they have to figure out who gets what at the beginning and only use what they have access to. Log in with my face. Yes. Apple, why don't you have that? You could put that somewhere in that giant notch. Imagine Apple's UMA is like two chefs sharing one big countertop. Both can grab the flour, the knives, or the mixing bowl anytime they want. AMD's is like two chefs with separate tables, and they agree ahead of time. You get the flour, and you get the bowls, and you get the knives, and no swapping mid-recipe. So check this out. Now, if we go to our GPU, we got 96 gigabytes available for the GPU. And you think this is great, right? Well, there's a problem. If I try to load a model here, let's say, I don't know, a larger model, because after all, that's why I want so much memory, so I can run larger models. Let's go with this Llama 3.3 70 billion, and we're gonna try to offload 80 layers. It's 74 gigabytes on disk. Should fit no problem, right? Oops, what's going on here? Failed to load the model. Model loading aborted due to insufficient system resources. What? I thought I had enough. What's going on here? I bought this computer, now I can't use it. All right, let's try this on the Mac. I have a couple of 70 billion ones here. Let's try this one, 69 gigabytes on disk, load model, all 80 layers offloaded to the GPU. Let's see what happens now. Oh, this is Q8. Wow, that's the quantization level. So a pretty good high quality model here. And look at that, memory used 120 gigabytes. I didn't have to say, oh, GPU gets this much. It just automatically does it because it shares the same memory. And if I say hi to here, how's it going? Is there something I can help you with? It works. But you know, we're not totally dead in the water here on this machine. There is a hardware setting you can adjust here called guardrails in LM Studio, where right now it's set to strict. So it's going to prevent you from shooting yourself in the foot by loading too big a model and making your system freeze. We can turn that off. You know, there's a bunch of other settings in between, but let's go for it. And let's go for this big one here again. Offload everything to the GPU and load. If we take a look at what's happening here and why it's taking so long, you'll see that system memory is still being used. Why is system memory being used? I thought we had enough available memory in the GPU to just load it in there. Well, we're using that too, but we're also using system memory. Failed to load the model. That's too bad, and that's 69 gigabytes on disk. We do have other 70 billion parameter models. They're just quantized more. So instead of Q8 or quantized to 8-bit, we can do Q4, which is quantized to 4-bit. It's half the size. So let's load that one. And again, the system memory is growing, and so is the GPU memory. And I'll tell you what's happening here. This is my assumption, but I don't see any other explanation. And if you know better, then you let me know in the comments down below, and hopefully everybody else will get to learn. But because I think this is not a true unified memory architecture, it first has to do what other systems with a discrete GPU do. They copy your model to memory on the system, and then that gets copied to the GPU memory, which is a separate space. And when it's discrete GPU, that's obvious. That data has to be copied from system RAM to the GPU RAM, and then it stays there to be quick. Here, it wasn't so obvious because you think that, well, we're on the same chip, we're on the same APU, they're unified memory. Why not just use the same thing? Well, I don't think that's what's happening here. So if we say hi here, it looks like it's working fine. And now that it's copied things over to the GPU, it's gonna be in there. Memory is still being used, but not as much as initially. As you can see here, initially we had a big bump. Now we're down to about half. But if we take a look at the GPU memory, now it's being used quite a bit, and there's our compute from the GPU when I ask my prompt, when I ask my query. So that's essentially the big difference here. Could I get the 32 gig version instead of the 128 gig version and be able to run smaller models? Sure you could, but the 32 gig version is not gonna give you everything that the 128 gig model will. For example, it will not run this model, because this model is way too big for it. And I made a few charts here. I collected some data. I can actually post some links down below. Here you'll see the different machines in different colors. Let's clean it up a little bit here. Let's take a look at the two Flow Z13 machines. And you'll see that, yeah, when it comes to these larger models, only the 128 gigabyte version will run those. However, the models that do run on both of them, the smaller models like this one right here, Gemma 12 billion runs on both. We're getting 24 tokens per second here on the 128 gigabyte machine, and we're getting 25.5 tokens when we set the 32 gigabyte machine to 24 gigabyte allocated to the GPU. A little bit even better here in this particular case of this model. If we zoom in on the 32 gigabyte machine, you can see the little bump that we get from going to the 16 gigabyte setting right there across the board from all the models. And that's actually consistent when we look at the 128 gigabyte machine as well. The 16 gigabyte setting gives us really good results. 64 gigabyte setting does not for some reason. Now you might wonder how the AMDs do against Apple Silicon. It depends, because one other thing plays a very key role in performance, and performance I mean speed, tokens per second. This is the M4 MacBook Air, and it has 100 gigabytes per second memory bandwidth. The M4 Max, 530 something. This machine is pretty decent. It's got 230 something, and in fact I ran the Stream benchmark, which is an industry standard for measuring memory bandwidth, and I got, for the Triad, I got 235 gigabytes per second. There's another machine coming very soon that's a little bit less than the M4 Pro chip, but the M4 Pro chip has a little bit more memory bandwidth, but it's gonna be about the same speed for tokens generation. There's another machine that's coming out, very close numbers, and I'm planning to get that in here to test, and that's the DigiX Spark, NVIDIA's own machine. Now if I run Stream on my M4 Max, I'm not getting close to the advertised numbers here. For the Triad, I'm only getting 316. For Copy, I'm getting 355, but that's not even close to the 500 plus that we're supposed to be getting. And finally, the M4 Air is giving us about 100 in the Stream results. So we know the Apple Silicon measurement of the Stream benchmark is pretty close to accurate. And that's why the MacBook Air numbers for the tokens per second are actually much lower than the AMD Ryzen AI Max Plus 395. Hey, I'm getting it. I'm getting it. Now, right off the bat, to get a sense of what these machines are capable of, we might as well run Llama Bench, which is part of Llama CPP, a pretty common tool that actually a lot of people use, including LM Studio under the hood. So we're gonna go Llama Bench. I compiled it, by the way, using Vulkan so that it uses the GPU on the AMD machines. And by default, it uses Metal on the MacBooks. So all we need to do is run Llama Bench and point it to the model that we wanna test. I'm just gonna do one as an example here so we can get a relative sense of how these models perform on these machines. And I'm gonna pass it the GGUF file. All right, so let's go. Here we go on all these. And here's the result on the MacBook Air. You can see the PP512 result, which is about 1500. That's the prompt processing result. And what's good about this particular benchmark is that it comes out pretty even across the machines. PP512, TG128 is text generation, and we're getting 101 tokens per second here. On Windows machines, you can pass in the NGL flag, which is how many layers you wanna offload to the GPU. Not how many, but what the percentage is. Let's see if that works on the Mac as well. We're getting slightly better numbers, but nothing tracked here. You can see the results are a little bit better on the AMD machine. NGL 99, let's redo that with NGL 100. So we're offloading all the layers, and we're sure to be doing that. And we're getting slightly better numbers here. For PP512, we're getting 6,173, and for text generation 159, 162 for the previous run. As you can see, we're using Vulkan here. Vulkan is a library that's cross-platform, so you can use it on Linux, Windows, AMD, RTX, all those machines. And here's the result for the M4 Max. The first result, I'm running it again with NGL 100, and we're getting slightly better numbers with that. At least for the prompt processing, we're getting better numbers, but they're pretty close, 7,000 or so. And text generation is the highest at about 240. That's Gemma 3 1 billion model. I'm not gonna do Llama Bench for all of them, just to give you a baseline here, how these machines relate to each other. I did recently review this machine from a developer perspective. Check that video out. I'll link to it right over here. Thanks for watching. Hope you enjoyed this one, and I'll see you in the next one.